So we'll do a little bit of review, and then last time we finished out by kind of planning out a class that we want to write, and so I'll have you write that class. And then we'll brainstorm other things we can make classes out of. So the theme of the day is creativity. So last time we talked about the 4 principles of object-oriented programming, those being encapsulation, so typically making things public and private, of which aspects does the user get to see and play with directly. There's abstraction, which is the idea of sort of rising above and referring to things generically. There's inheritance, which lets us reuse code and extend code that we've already written. And then there's polymorphism, which is being able to, of the multiple correct options, choosing the one that applies to this moment. So we talked about a lot of definitions last time. Classes being the file that contains the code for an object, or for a reference type. An object being an actual instance. And so, for example, last time we talked about int cell, and we had int driver. And so int cell is a class. This int cell.java, that's a class that defines the reference type int cell. And then when we actually go to make a variable, we've now created an int cell object. And so that's the concrete instance. And so that's X, the object of type int cell. And so that type that we've defined, when we see it in use over here, remember when we declare variables, there's the type name and then the variable name. And so int cell is now our reference type. This is also called an abstract data type, which we have created. A class can have different members, which are different things that do stuff for a class. Generally, the properties, the behaviors, and the constructors. And so the 3 members of a class are fields, methods, and constructors. A field is a property. And so for our int cell class, this is the property where we've got the integer that we're going to keep track of. We've got our methods, our behaviors, things that we're doing. So we're getting the integer, we're setting the integer, we're printing the state of this object. And then we've got a constructor, which actually sets up the object when we do this right-hand side of the equal sign. So fields are typically declared variables. Methods are functions that live in the class. Constructors are how do we set this up when we create this object. Okay. We talked about visibility, which is public. So anyone in any file, any folder can access this and see it directly. Private means no one outside of my file can see or access it directly. If we don't have anything, then that's package visible. So only the things in this folder can see it. And then protected, we'll talk about later. So protected is package visible plus. So we'll talk about the plus later. Fields can have visibility. And so over here in int cell, we've made the int private. So no one outside of this file can access it. Constructors are, when we define a constructor, that tells us what happens when we instantiate. And so if we don't have anything, then all our primitive fields are initialized to 0 or false, and all our reference variables are initialized to null. And we saw that last time. Our constructor name, so in int cell, we've got the constructor name, which is the same as the class name, which is the same as the file name. and it doesn't have a return type. So even though it looks like a method, it's not really a method. We've got setters and getters, and then we'll get into combination lock. Okay, so my plan for until maybe 2:15. So last time we went over this where like what is a combination lock? It takes three numbers as input, and we want to be able to set the combination, open it, and close it, and change the combination. And so I asked you to think, what are your fields? What are your methods? What are your constructors? And we came up with some ideas where we have some, so there's options here where we can store the field as an array, or we can store the field as a series of integers. In the constructor, we can take in as parameters those integers, or maybe we just use a scanner. That's also an option. And for our zero parameter constructor, we have 0, 0, 0. And then in our open method, we want to check it against the numbers that we get. And then close in and change combo we didn't quite get to. So what I want you to do is let me duplicate this, and I will take away my scratchy notes. And so I'm going to put you, I think I'm going to put you in the groups for your labs for the next lab. But this won't count for a grade. And maybe half an hour, 45 minutes, I'm going to have you work on this. Try and write a class that does this. And so we've got the ideas of here's the fields, the constructors, the methods. And so you try and implement this. And then when we come back, I'll show you my way of doing it, and then we can go from there. All right, thank you for that. I hope that was helpful in trying to understand, here's all the terms that we use. So ideally, you've got your version. I'm gonna write this up fairly quickly and tell you how I would have approached it, and then you can compare what your code did to what my code is. They're probably not going to be the same. You probably have made different choices, and that's okay. So just to show you, like, here's an easy way for how I did it. All right, so thinking of this, it takes three numbers to open, and that combination has to be secret. So some of you have an array for the three numbers. I'm just going to do, I'll call it num1. Ooh, let me show you this. I'll call it num1, num2, and num3. But I'm going to type this line 3 times. So, I always forget source. No, edit. Yeah. Toggle block selection. I can draw like that, and then I can say private, int, num, and then I'll add the numbers later. Yeah. Okay, so edit, toggle block selection. And the option for the keyboard shortcut for me is Option Command A. So on Windows, it's probably Option or Alt Control A, but chances are it would show next to it. Okay, and so to get out of it, I think I have to type that again. And so now I can just add the numbers. So that's fun and helpful. All right, so those are my fields. And then a lot of you, what I saw is you also have a Boolean field for is the lock open or not, which I agree with, and I'm also going to include. Okay, so when we've got a class, we have setters and getters. The question is like whether we want them or not. So our combination is supposed to be secret. Does it make sense to have a getter to say, get me num1, get me num2, get me num3? No, because we want to keep that information private and check it in the open and change combo methods, right? But I think it would be nice to have a getter for is open. I don't want to have a setter for sure, because that would just like either close the lock or open the lock and bypass the code entirely. But I do want a getter for is open. So here's what I could do. I could type it of public. Do I need static? No, because I'm going to be making a ComboLock object. And if I'm making an object, I don't need static. Static only requires static is not required if I'm going to have a controlling object. If there is no controlling object, I will need static. However, I am going to have a controlling object here, so no static. So public, the return type for is open is going to be a Boolean, true or false. Can do that. Another way of doing it, I'm going to delete this. I'm going to show you how to get it back. Oops, meant to delete the whole thing. Delete the whole thing. I'm going to right click on my code. I'm going to go to source. Right click on my code. Go to source. And then generate getters and setters. And I really only want, so then this dialog box shows up, generate getters and setters. And it's like, which ones do you want to create? And I can click this little arrow to show the drop down of here's all the ones I could do. I want almost none of them. The only one I really want is just the is open. So I want to select almost none of them. I just want to click the little arrow next to is open and select is open. Okay. I'm going to generate, and it's going to give me exactly what I just typed. All right, we'll go over this again in another example. All right, so that's my setter. Let's make my constructor. So the name of my constructor has to be ComboLock. I'll show you what I did. Oops, oh, I need parentheses and then that. I'll show you what I told one of the groups of, let's say I accidentally named it. Ha 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 ha, it warns me. Okay, I'm gonna ignore it. So let's say by accident, I named my class lowercase c ComboLock. This is in violation of a Java convention, which asks very nicely that all of your type names start with a capital letter, because reference types start with a capital letter, so we don't confuse everybody. And if I wanted to change the name of my class to match conventions, I can, let's see, I think I can do it in different places. I find that name that I want to change somewhere. I right click it and I go to refactor, rename. I can type capital C combo lock, and it changes it everywhere. So now the name of the class, the name of the constructor, the name of the file all match. This also works if I wanted to rename a variable. You can right-click it, go to refactor, rename, and name it whatever you want. And wherever else it lives, it'll update that. Okay. Okay. The question is there content assist? Nope. I know in VS Code there's like, you can duplicate a line. Yeah. Num1, num2, num3. This is my, what we call a zero parameter constructor. The parentheses are where the parameters go, and there's nothing there, right? Zero parameter. And that satisfies the otherwise clause. Now we need another parameter. I could type it all out, or I could go to source, generate constructor using fields, and then I don't want to set is open from my parameters. So just num1, num2, num3. And then it does it for me. And so I will add at the end that this is open is equal to false, just to make sure. So again, right click, source, and then generate constructor using fields. I will note that if you're trying to do this in VS Code, it's a really similar process. Like the right click is just like the menu is a little bit different, but you can do the same thing. Okay, so that's that constructor. Now I want to open it. And in order to open it, I need to know the existing combination. And so I'll have an if. So if so this is where like naming can be tricky, where my parameters are named num1 and my fields is also named num1. And so the way that I check the parameter against mine is with the keyword this. And so one option is to use this dot num1. Another option would have been to like change to like num a, b, c. Like I could change the parameter names if I wanted to. But in this case, I don't want to. And that's not a hard and fast rule. That's just my preference in this situation. So if the first number matches and the second number matches and the third number matches, then the lock is open and I can print that. And then if they didn't get it, maybe I can print, you did it wrong. What if I did this? If I did that, would it be good?
Yes.
Right. So if you take discrete math or computer systems later on, you're going to learn a lot about like logical and logical or, where this will be true if only one of them ends up being true. And so if the combination is 1, 2, 3, and they guessed 1 and then 51, 52, then it would let them in, which we don't want to have happen. So in fact, we do need the ampersands. We can further add some boundary cases to maybe check. So maybe I'll say if it's open, then no, no, go back. So I can say if the lock is open, then just print it's already open and return. I heard. That's correct. However, right. So the idea is if the lock is open, I don't want to bother entering the combination because there's no point. And so I can do this in a void method. I'm not returning anything. There's nothing after the return. I'm just saying when it hits the return, the execution will stop and we'll go back to whoever called us. So this is me saying, don't bother checking the combination. There's no point. Close is easier because we don't need to check anything. And so maybe we can check this. So if it's already closed, then we can just print it's already closed and then return. Else print the lock is closed and close it. All right, I'm moving on in the interest of time. I will post this on Canvas after class. You'll all have access to this. So change combo, this is where the parameters may seem a little bit excessive. Again, you could make different decisions. If you want to get this information via a scanner, you could do that. But for now, I'll just have we'll call it N1, N2, and N3. And then N1 for new N1. And N2 for new num2. And N3 for new. So if I type the /** to generate my documentation, then I can write a little bit the new second number, the new third number. So I could do a scanner instead. But so to change the combination, you need to know the existing one. So I'll say if this dot num1 is equal to n1, the same kind of thing. This dot num2 is equal to, two equal signs, num2. I called it N2 in this case. This dot. So if the first three numbers match, then I can say this dot num1 is now equal to nn1. This dot num2 is now equal to nn2. This dot num3 is equal to nn3. Sounds good so far? Did I forget anything? I don't think so, but it feels like I'm missing something. Let's look at our specifications. The key, yeah, okay. So there's some stretch goals that we could have for this project. So it takes three numbers to open, input in succession, order matters. I would argue that we have that. Combination is secret. These are private, so I'm okay with that. We've set it in the constructor. We have an option for 000. We've got open, close, and change combo. So yeah, so if we have a key, we could use that to bypass. So maybe that involves something like, am I outside the method? Now I'm outside the method. Maybe we overload that of if they have the key, then like has key and then change the combo for these guys and you bypass the checking entirely. That happens every once in a while in this building. The other thing I could do is I can check whenever I get a new number of check if it is like less than 40 or that it's greater than or equal to 0 so that it's not negative. So greater than or equal to 0 or less than 40 to match like an actual combination lock. And so that's pretty much it. Let's do a constructor really quick. We'll make a new class. I'll call it ComboLock driver. And I'll give it a main. And then I can say ComboLock. That's my type name. I'll call it C. That's my variable name. Equals new ComboLock. And C.open with 000 should work, right? Because I give it no parameters. So it should set 000. And if I give it 1, 2, and 3, and then C2 dots open 1, 2, 3, then that should work. Oops. Change combo 1, 2, 3, 4, 5, 6. And then let's open it with our new 4, 5, 6. Right. So this is me testing. Here's all the functionality of my object. And so we have our new combination lock. The passcode should be 000. So I'm going to test that. Then we have another one. Passcode should be 1, 2, 3. I'll test that. I'll change the combination. Then I'll open it with the new combination. If I run that, oh, I guess I'll close it in between. So it opens, it closes, it opens. If I try and give it 4, 5, and then an incorrect number, then it prints incorrect. So nothing gives me an error, and it behaves how I expect it to behave. Hooray, great job. Any questions on ComboLock so far? Great. All right, we did that. So now I want to have some rest of the time for us to be creative. So we've seen, like, we've created a very simple class for the int cell. We've created a class a while ago for our smart house, and we created a combination lock. And so in your groups, I'd like you to think about, so write on the board as you brainstorm, of what sort of things can classes model. So what sort of things can you represent in a class? And in particular, what would the fields be? What would the methods be? And to kind of think about how you would construct them. Is that clear? All right. I'll pause the recording and distribute markers, and then we can go for it. I'm just going to briefly go over, here's the stuff that I liked from what you did. So let's think of the car example, and then I'll do the expo. So the idea with the car is, let's say our fields are like the odometer and the gas amount and maybe the mileage. And so then when we talk about a method called like drive for X amount of miles, then something happens to our car. Like when I get in my car and drive to Chipotle, that's maybe, I don't know, let's call it 5 miles. And so my odometer will add that many miles. So if my odometer is 1,000, then after driving to Chipotle, my odometer will be 1,005. So a property about my car will change. Then my gas amount is going to be decreased, right? Because I'm going to have less gas than when I started. And it's going to be the number X times my mileage. So if I get like, let's say I get 10 miles per gallon, and then I drive, which should be 1 over. Or no, let's do X times 1 over mileage. And then I drive 5 miles, then that'll take me down 2 gallons. I'm not sure if that math works out, but do you get what I'm saying? Like if I drive 5 miles and I have a certain mileage, then do that multiplication, and then that's how much less gas I have. Right? So the properties about my object have changed. And similarly for an expo marker, if I've got some amount of ink, and then if I have a method called write, then maybe whenever I write with my expo markers, I lose 10% of my ink. And so then as the course of using my object, the state of the object changes. So eventually I'm going to get to an object that doesn't have any ink, right? So that's the idea, where I see a lot of, like, for a grocery store, like is it open? Is it closed? Or like, is the library open or closed? But I want to bring us to a more advanced idea where these are things that can have properties that we care about. Like a library has books, and we want to be able to check out a book or check in a book. So starting to think less of like a Boolean type thinking and more on like what actual attributes do we care about? And how do we write methods to change those and move us along? That's what we're trying to do. Next time we'll talk more about like the different methods that classes can have. Next time I'll also introduce homework 3 because homework 2 is due today. Reminder that if you want your exam back, to make an appointment with me, that appointment link is on Canvas. And I think that's everything. So I will see you on Thursday.